Hello, this is question 6 on your June 2019 AES paper from AQA, and it's a series of trigonometric equations. So you have to show that cos theta equals a half is one solution for this equation. So if we have to solve this equation, what we are going to do is to have everything in sine or cos, and the best way is to use that sine square plus cos square is 1, so we can substitute this in terms of cos square. So that's the first thing we're going to do. 6, 1 minus cos square theta plus 5 cos theta is 7. We are expanding the bracket, so we have a quadratic equation because we have something in cos x theta and something cos square. So let's going to rearrange in a nicer way. So we have 6 cos square minus 5 cos theta and 7 minus 6 plus 1. Yeah, so this is a quadratic. So it's like having 6x squared minus 5x plus 1 equals 0. So what we're going to do with this is factorize, and when we factorize, one of the solutions is going to be cos theta equals a half. Yeah, so if we solve this quadratic, one of the solutions is a half. So cos theta is going to be 1/2. Yeah. This is the first one. Then the second one, it says find all the values of theta that solve the equation. And this equation is precisely the one that we were doing here. So what we are going to do is to find the other solution here, which is cos theta equals a third. So if we factorize this, we will have really, I think it looks better, 2 cos theta minus 1, 3 cos theta minus 1 equals 0. Yeah, and from here we have cos theta is 1/2, and from here we have cos theta is 1/3. And if we want to solve it, what we are going to do is to work with these two possibilities. So cos theta equals a half, so the first solution give us that theta is 60 degrees. Yeah, just doing cos minus 1 of a half, or if you remember that is 60, that's perfect. And we are going to find the next solution. This is the principal solution, and we need to find the next solution in the 360 interval. So we can think of theta is 60, so it's here, and the equation is in cos. So we are looking for another value that gives us the same cos, which is going to be the symmetrical in the x-axis. So here, how you find the other solutions is really up to you. I like using the circle, but you can use the graphs or you can use the cast diagram. So the next solution will be 360 minus 60, which is 300. Yeah, so these are the two solutions in the interval for cos theta equals a half. The other option is that cos theta is 1/3. And when you do cos theta a third, you get that theta is 70.5 degrees, but you have to round to 1 degree, to the nearest degree. Yeah, so 71 degrees. So if we think the same here, instead of 60, I have 71, so it's quite similar. This is 71 degrees, and we look for the same cos, so our angle is going to be 360 minus 71, so the symmetrical here. Yeah, and that is 289 degrees. So these are my solutions to the nearest degree for this equation. Yeah. The next thing is find hence, so we are going to use that, find all the solutions of the equation. And this equation is the same, but I have 2 theta now instead of theta. So the first thing I have to do when that happens is to change this interval so we don't miss any solution. That interval for 2 theta is going to be 0, smaller or equal than theta, smaller or equal than 360 times 2. So I'm multiplying everything by 2. Yeah, so my new interval is this one. I have to find all the solutions in this interval, which means apart from these 4, I may have more because I can just go around and still will be in my interval. So I can, if I think of these 2, I have 60 and 300. If I add 360 to this one, because I go around once, is going to be still in my interval. So let me 60, 300. So we have that 2 theta is going to be 60, 300. And if I go around one whole turn, is going to be 60 plus 360, which is 420, is still in my interval. And this one, if I add 360, I have 660, which is still in my interval, because it's below 720. If I add 360 to this one, is above the interval, so that's enough. And once I found all the answers in my interval, then I can divide by 2. But that's the last thing I do. Yeah, I'm going to divide by 2 to find theta. So theta is going to be 30 degrees, 150, 210, and 330 degrees. But I'm going to do the same with the other group of solutions, which are the 71 and 289. So I had 71 and 289, no? And I'm going to do the same. I can go around once, so 360 plus this one, and I'm in the interval, so it's 431, and 360 plus 289 is still in the interval, so I have 2 new solutions. And the last thing I'm going to do is to divide this by 2. So theta is going to be, this one was 70.5, so we round up, but when we divide by 2, we have 35 instead of 36. But you will be marked correct anyway. 145, 215, and 325. All rounded to the nearest degree, but that's what I asked. And that's it. That's how we find the solutions to the same equation, but when the angle is to theta. We first transform the interval, we add all the solutions that we can add because our interval is larger, and then at the end we divide by 2 to have the theta. Yeah, and that's all with this exam question.